Alright, hi guys. So unfortunately I'm not there. This was supposed to be yesterday's lesson, but obviously we didn't get to it, so I'm going to have you watch this video so that we can get caught up and we aren't behind the other classes. So this lesson should go pretty quick. It's the perimeter of irregular shapes. When we're talking about the word perimeter, we've spoke about it this year quite a bit, and that just means it is when you add up the lengths of all sides. It is the distance around the shape. So when I have a perimeter looking nice, like I have for number 1 and 2, I am able to just count the boxes on each side. So I have 3 on all sides here. This is a square, so the perimeter is just 3 plus 3 plus 3 plus 3, which is 12. And then same thing here, I'm able to just count 1, 2, 3, 4, 5 on each side, and then 1, 2, 3, 4, 5, 6 on each width. So I just add 5 plus 6 plus 5 plus 6, which gives me 22 as the perimeter there. When I have something like this, I have a slanted line now, so I'm not able to just I'm not able to just count those boxes because the line is slanted. So I need to use the Pythagorean theorem to find that missing side, since this is a right triangle. So I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then I'm going to use the Pythagorean theorem to find my missing side. So I have 6 squared plus 6 squared equals x squared. So it's 36 plus 36 equals x squared. So that is 72. Then I radical both sides, and I get radical 72 equals x squared. I want to simplify this radical, so I'm going to use my calculator to do so. And I'm going to do 72 divided by x squared and find the largest pair of whole numbers, which is 6 and 2. So my simplified length is 6 radical 2. So when I add up all the sides, I have 6 plus 6 plus 6 rad 2, which is 12 plus 6 rad 2. The only thing that gets tricky here is you cannot combine this 12 and this 6 because this 6 is attached to the radical 2, so they have to stay separate. So it's 12 plus 6 radical 2. You never combine any radicals with any regular numbers, you keep them separate. When I have some irregular shapes like I do for the rest of the classwork, you need to use the distance formula or use the Pythagorean theorem to find the missing sides. So for my straight sides here, 1, 2, 3, 4, 5, I can just count. So that's nice and easy, but then for my other sides, BC and AD, I need to find out what those line segments are. So I can either use the distance formula or I can use the Pythagorean theorem. They gave us the coordinates for these points. So you can use the distance formula nice and easy, or you can use the Pythagorean theorem. I'm going to use the distance formula because I like the distance formula better, but it's up to you how you want to do it. And then you're just going to plug everything in to the formula we learned yesterday. And you can plug everything in here, everything underneath the radical into the calculator. And you're going to end up with 26 when you do that. So your distance is rad 26 for BC. And then you're going to do the same thing for AD. And again, again, you can plug everything underneath the radical into the calculator. And you're going to end up with, I don't know why I keep drawing a huge radical. Rad 34 there. And both of those radicals can't be simplified, so you don't have to worry about simplifying them. And then your perimeter, you're just going to add everything together. And again, you don't combine your radicals or anything. The only thing you're combining is 5 plus 7, which is 12. So you have 12 plus rad 26 plus rad 34 as your answer for your perimeter. Looks a little weird because there's a lot going on in that answer, but you do not simplify anything there. Then you're going to do the same thing for number 5. Here you just have 4 different sides, and you can't count any of them. So you have to use either the distance formula or the Pythagorean theorem on all of these. So I'll show this one using the Pythagorean theorem just so that we can see how it works. So here I have right triangle with sides 1 and 3, and then I'm solving for DC. So I have 1 squared plus 3 squared equals x squared. 1 plus 9 is x squared. So x equals rad 10. And I can't simplify rad 10. Then I'm going to do the same thing for this side. So I have 1 for this length and 4 for this length. So I'm going to say y equals 1 squared plus 4 squared. So y squared, my bad. So y squared equals 17, radical both sides. Y is radical 17. Then I'm going to do the same thing for side AB. I have 1 and 5. So I'm going to call that side Z. So Z squared equals 1 squared plus 5 squared. And then I solve for Z. And again, that can't be simplified, so I just leave it. And then lastly, I have CB. So I have 1 and 2 as my lengths. So I'm going to call this one, I'll call it B. B squared equals 2 squared plus 1 squared. So that side is radical 5. And then your perimeter, you just add together all of those sides. Rad 17 plus rad 10 plus rad 5 plus rad 26. And you do not combine anything underneath these radicals because you can't. That would be mathematically incorrect. So that was number 5. And lastly, number 6, the endpoints of one side of a regular pentagon are -1, 4, and 2, 3. What is the perimeter of the pentagon? So a regular pentagon, anytime they use the word regular in front of a shape, that means that all sides are equal. And then a pentagon has 5 sides, which you guys should know. Also, the prefix pent means 5. So you just have to find the length of this side and then multiply it by 5, and that will be your perimeter. So I have my distance formula. I'm going to say -1 minus 2 squared plus 4 minus 3 squared. And then I'm going to plug this into the calculator. And you end up with radical 10, which cannot be simplified. And then you're just going to multiply rad 10 by 5, or you can add rad 10 5 times. and you get 5 radical 10. Or you can just multiply it by 5. Up to you, which is choice 2.